Welcome to this video on subatomic particles. In this unit we're covering atoms and elements, and for this video we're going to look at what are the parts of an atom that they're made of. What are the things that they're made out of? And we call them subatomic particles. Subatomic meaning within the atom. So you've probably heard of the three main subatomic particles that we're going to focus on, which are protons, neutrons, and electrons. There are other ones, but these are the three that are really involved in the chemistry that we're going to focus on in this class. So we only worry about these three. Let's first start talking about their electrical charges. Protons are positive, electrons are neutral, and neutrons are neutral, and electrons are negative. It's important to know that neutral means no charge. It's not that it has a charge of 0, it means that there is no charge. Now we're going to look at their relative mass. They're all really, really small. So to say that how many grams or how many kilograms each one had, this would be kind of pointless because they'd all be really long, infinitesimal amounts. So instead we just compare them to each other. And we say that but from what we've studied, protons and neutrons are about the same in mass, so we just count them as one. But electrons are much, much smaller. They're a very small fraction. They're so small that even when you have the highest number of electrons, which is in the early hundreds, like 110, 120, you still don't come even close to one proton and neutron. So because of this, we don't even worry about electrons when we do the mass. So when we calculate the mass or mass number of an atom, we use protons and neutrons, and this is going to be important later on. To represent each one, we're going to use these little symbols here. We're going to use a P with a plus sign for protons. We're going to use an N with an O for neutrons, and an E with a negative sign for electrons. Now, let's talk about where we find each one. Protons are found within the center of an atom in an area called the nucleus. Also in the nucleus are the neutrons. They're found in the center of the atom, and they're mixed in with the protons. Now, electrons are found in orbitals that surround the nucleus. Now, you may have heard of something other than orbitals before. This may be a new term for you. Orbitals are areas where electrons are likely to be found. Due to their unique nature, electrons, just by trying to locate them and using instruments to try to find them, we affect where they are. And so as a result, we can never actually know where they are. We can only do places where they're more likely and less likely to be. We can only do probabilities. So if you look at the current model of atoms, you'll see we've got the nucleus still with its protons and neutrons. But instead of having these set orbits like you've probably seen before, there was like electrons flying around in a set path. Now we use this cloud to represent where they are, because these clouds show we know there's a good likelihood that they're in this place here. And darker the cloud is typically represents the higher probability. Now we're going to focus on how do we find the number of each one. How do we know how many protons an atom has, how many neutrons, and how many electrons it has? But in order to do that, let's use an example. We're going to use an example of carbon-14. 14 right here, a number right after, this represents the mass number. Remember, the mass from before was the protons plus neutrons. Keep that in mind. So, to know the number of protons, we look at the atomic number. This is the main number that's on the periodic table. You can find it typically right by or right above the symbol, and it's always a whole number. And it's always the same for that element. So I look on the periodic table and I find carbon. Carbon has an atomic number of 6. Therefore, it has to have 6 protons. That is, by definition, what makes an atom a carbon atom, having 6 protons. So we know, since it's carbon, it must have 6 protons. In order to figure out the neutrons, we're going to look again at this mass number that's right here. Remember, the mass only deals with the protons and neutrons. And if we know it has 6 protons, that means the rest of this 14 must be the neutrons. So to find the neutrons, we take mass number and subtract the atomic number. So we're doing 14 minus 6, and we get 8. There are 8 neutrons. Now, electrons, in order to have what's considered a neutral atom, an atom with no charge, you have to balance out all your positives with the same number of electrons. So if there's not any mention of a charge, doesn't say anything about a charge here, then we know that the electrons must be the same as the protons. So we're going to say that they're the same as the protons when it's a neutral atom. We're going to talk about when it's not in just a minute. But so since it's a neutral atom, since there's no charge indicated, we know that it's 6 protons, or 6 electrons. Now, what happens when we add or take away each one of these particles? So again, we're going to look at carbon-14 with the 6 protons, 8 neutrons, and 6 electrons. And we're going to say, what happens when we add or take away a proton? Well, I'm going to add a proton, and that changes the element. If I add 1 proton, now I have 7 protons, but that changes the atomic number, because by definition, the atomic number is the number of protons. And I look on my periodic table, the element with the atomic number 7 is nitrogen. So now I have nitrogen. It's now no longer carbon, it's now nitrogen. All right, now let's go back to having 6 protons, 8 neutrons, and 6 electrons. And now we're going to add a neutron. So I add a neutron, and that's going to make it have 9 neutrons. Well, that's going to change the mass. The mass is now going to go, it has 6 protons plus now 9 neutrons. Now it's got a mass number of 15. So now it's no longer carbon-14. It still has 6 protons, so it's still carbon. But now we say it's carbon-15. That's a different isotope. Elements, they're atoms of the same element, but with different masses. This is carbon-14, and this is carbon-15. They are 2 different isotopes. Now let's talk about electrons. What happens when we add an electron? Well, that's going to change the type of ion. Now we have a charged atom. That's what an ion is. So I'm going to add 1 more electron. So now I have 7 electrons. I'm going to go back to having 6. Since it's carbon-14, it still has 6 protons. But now the number of electrons is 7. Well, now we have 1 more negative than we have positive. And as a result, now we have a carbon with a -1 charge. So we write the ion symbol with C for carbon and then a -1 over here in the top right. And we're going to take a break and stop this video here, and we'll have a part 2 where we talk about how to read these symbols and talk more about isotopes and ions.